In this video, I want to take you through the process of partializing fractions with linear factors. When we are expressing a fraction in partial fractions, we'll be splitting a single fraction into multiple fractions. We'll be expressing as a sum of multiple fractions. And in this case, we are talking of the factors that are linear. When we are saying linear factors, we are talking of the factors where the highest power of x is 1. So that we will be concentrating on such fractions where the highest power of x in each factor is 1. Right, so before we work out a few examples, let's go through these few steps that we'll be following when we'll be working out a few examples. So the first step is to express the denominator as a product of its factors. In other words, we are saying factorize the denominator completely. Right, let's move on to our second step, where we are now saying let the fraction be identical to the sum of the fractions where each linear factor is a denominator of an unknown constant. For example, you can make use of A, B, C, or D. Right, let's move on to the third step. Clear the denominators by multiplying each fraction by the common denominator and form an identity that has no fraction. We are now forming an identity that is independent of denominators. Right, let's move on to the fourth step. Use the concept of finding unknown coefficient in identities to find the values of the unknown constants that we have used as the numerators in step 2 there, A, B, C, or D. Right, then the fifth step is to substitute the values calculated in step 4 into fractions in step 2, and that will be our final answer. As simple as that. Right, let's move on to our first example. Express 5 plus 1 all over x minus 1 factor of x plus 2 in partial fractions. In this case, if you look at the denominator here, we have two factors, x minus 1 and x plus 2. These are the two factors. And in each of these factors, we have the highest power of x 1. So this is a linear factor. This one is also a linear factor. So since we have linear factors here, we are saying this is very simple. Having these linear factors, there is a possibility of having a fraction where this first factor is the denominator. So we don't know the numerator, so we're going to use a to represent the numerator of this x minus 1. Right, there is also a possibility of having x plus 2 as the denominator of the other fraction. So since we don't know the numerator of that fraction, we are going to use b to be the numerator of that fraction. So we're going to say, we're going to rewrite this this fraction, and we want it to be identical to the sum of these fractions, where this a is representing an unknown numerator of this denominator. This b as well is representing an unknown numerator of this factor x plus 2, like this. Right, so the next step is now to clear the denominator. Let's clear the denominator by simply multiplying every fraction by the common denominator. And in this case, our common denominator is x minus 1 factor of x plus 2. So we're going to multiply every fraction by this fraction. Right, so if we multiply the left hand side by this common fraction, this common denominator, we are going to remain with x plus 5 only on the left hand side, which is identical to if we multiply this fraction a over x minus 1 by this common denominator. Obviously, this x minus 1 will cancel with this x minus 1 and will remain with x plus 2, this x plus 2. So we'll remain with the a being a factor of x plus 2. Right. If we also do the same with this second fraction, b over x plus 2. If we multiply this entire fraction, b over x plus 2, if we multiply it by the common denominator is x minus 1 factor of x plus 2. If we multiply this fraction by that common denominator, this x plus 2 will cancel with this x plus 2, so we remain with x minus 1 being the factor of b. So we are saying we will end up having an identity which is independent of denominators like this. Right, then from there we are now applying the concepts of identities, where we'll be eliminating one unknown. So if you haven't watched a video on identities, I have posted a video on identities where we were finding the values of unknown coefficients. So we're going to apply those concepts. Right, so in this case we are going to let x be equal to 1. By so doing, we'll be eliminating this one, the whole of this one. We'll be eliminating the whole of this one, because if you substitute 1 here for x, we get 1 minus 1, which is 0. So 0 by b is 0. So if we substitute throughout like this, we find out that 6 is equal to 3a, like this. Then if we divide both sides by 3, we find out that a is equal to 2. Right, let's take this one as our value of a. This is our value of a. So we are saying the numerator of this fraction, the numerator of x minus 2 here is 2. Right, let's also find the value of b now. We want to find the value of b so that we can substitute it back into this fraction. Right, let's now move on. In this case, we want to eliminate a so that we remain with b and we solve the equation for b. Right, so to eliminate a, we have to make sure that this factor x plus 2 is 0. So for this one to be 0, we just equate this to 0 and take 2 to the other side. So for this one to be 0, x must be equal to minus 2. So let x be equal to minus 2. Like this. If x is equal to minus 2, substituting minus 2 throughout like this, we find out that minus 2 plus 2 is 0. Right? Then we remain with minus 3b, which is equals to minus 9, like this. Then if we divide both sides by minus 3, we get the value of b being equal to, we find out that b is equal to 3. Now that we have b, we have the value of b, which is 3. We have the value of a, which is 2. We can now substitute those values back into this identity. Right, for a we'll be substituting 2, for b we'll be substituting 3. Right, so we end up having an identity of this form. Right, and we have expressed this single fraction as a sum of these two fractions. So we have partialized the fractions. Right, let's move on to our second example. Right, express this one in partial fractions. The first thing is to make sure that this one is, in terms of its factors, we want to factorize the denominator completely. So let's factorize the denominator completely. If we factorize this one, we get x plus 2 factor of x plus 3. So we are going to do it this way, like this. We have these factors. We have x minus 2, x plus 2, and x plus 3. So we have a possibility of having 3 fractions since we have 3 factors in the denominator. So since we don't know the numerators, we are very sure of the denominators, but the numerators, we don't know the numerators. So we're going to use a, b, and c to represent the unknown numerators. So the next thing is to clear the denominator. Let's clear the denominator here. We are multiplying every fraction by the common denominator. In this case, the common denominator is x minus 2 factor of x plus 2 factor of x plus 3. So if we multiply the left hand side by the common denominator, we remain with 2x plus 2x squared plus 2x plus 8 being identical to a factor of x plus 1, factor of x plus 3, right? B, factor of x minus 2, factor of x plus 3. Then C, factor of x minus 1, factor of x minus 2, factor of x plus 2, sorry, like this. Then from there, we now want to eliminate two unknowns. We can't eliminate one in this case, because if we eliminate one, we'll remain with the two unknowns. So we are going to eliminate two unknowns, then we concentrate on one unknown. So we are going to let x be equal to 2, and if we substitute 2 throughout, we find this expression. And if we simplify the left hand side, we find 20. The right hand side, we find 20a, because all these are zeros. Right. Then dividing both sides by 20, we find out that a is equal to 1, like this. Right? Let's also move on. We now want to find the value of b and c, so we're going to eliminate two unknowns again, including a. In this case, we definitely have to include a because we now have the value of a, so we have to eliminate a and any other, either b or c. So let's move on to our next step. Now let x be equal to minus 2. If we substitute minus 2 throughout, we find this whole expression like this, right? Then if we simplify the left hand side, we find 12, right? Having 12 there, right? Simplifying the right hand side, we find minus 4b, and all these other terms are zeros. Then let's simplify here. Minus 4b is equals to 12. Let's divide both sides by minus 4. We find out that b is equal to minus 3, like this. Then from there, let's now eliminate a and b, since we now have a and b. So for us to eliminate a and b, we're going to let x be equal to minus 3, sorry. So if we substitute minus 3, we get this expression, and if we simplify, we find out that 20 is equals to 5c. All these are zeros. This one will simplify to 0, since we are multiplying the whole of this one by 0. This one will also simplify to 0, so we remain with 5c being equal to 20, which will give us c is equals to 4 if we divide both sides by 5. So c is equals to 4. Now that we have the value of a, the value of b, and the value of c, we can now substitute those values in the initial identity like this. Right, for a, we can substitute the value of a. For b, we can substitute the value of b. For c, we are going to substitute the value of c. So we end up having an identity like this, right? And we have partialized this one. We have expressed this one in partial fractions. It was a single fraction on the left hand side. It was this single fraction that we have splitted into this first fraction, this second fraction, as well as this third fraction, like this. So this is our final answer. Right. We can now move on to our third example. Express this one in partial fractions, right? As usual, let's factorize the denominator completely. Let's factorize the denominator completely. We can just take out x there. We remain with something like this. X factor of x plus 7. Then there's a possibility of having two fractions here. So the first fraction will be having the denominator x, the second one having the denominator x plus 7. So we are going to let a be the numerator of x, b being the numerator of x plus 7, like this. Then as usual, let's clear the denominator by multiplying every fraction by the common denominator. So we remain with the 10x plus 11 on the left hand side. On the right hand side, we remain with the xb plus a factor of x plus 7, like this. Right, we now want to eliminate 1. We can let x be equal to 0 in such a way that if we substitute 0 here, we'll be eliminating bx. This one will go. We remain with 21, because if we substitute 0 here, we remain with 0. 10 by 0 is 0, so we remain with the 21, which is equals to 7a. And if we divide both sides by 7, we get the value of, we get 3 as the value of a. So a is equals to 3, right? Let's move on. This time we are now eliminating a. We want to find the value of b. So we're going to let x be equal to -7, like this, right? Let's substitute -7 throughout and simplify. We get -49, which is equals to -7. And if we divide both sides by -7, we get the value of b being 7, right? So having the value of a and b, we can now substitute those values in this identity. For a, we'll be substituting the value of a that we found in here. Then for b, we'll be substituting 7. So we are going to rewrite this identity, but substituting 7 for b and 3 for a, and this is our final answer. Right, here is your exercise. You can try these 3 questions. Right, and here are the answers. Thank you very much for watching. Please don't forget to subscribe to my YouTube channel.